Hello everyone, I believe we're streaming. Let me just pull up the stream on my phone so that I could make sure that the audio is working and all that jazz, and we will get right into the content. Hello everyone. Yeah, okay, audio is working. Excellent. So, welcome back everybody to the NNFS tutorial series in Golang. Sorry it's been a few days since the last upload, but I've been spending the last few days figuring out how to plot things in Golang because it's been a mess. Because we are starting a new part, training data. We're going to be getting training data, and I have to figure out how to manage data in Golang because I've never actually done it before. So that's what I've been doing the last few days, and I'm now here to bring it to you. So quick intro into what we're doing. We are going through and this is the sixth part of the ongoing tutorial series, going through the neural networks from scratch in Python book, but I am taking all the code and turning it into Golang. It's been a lot of fun. In order to follow along with this series, you're going to need to know how to program in Golang. And if you want to follow along with the series, you should watch the previous videos. Link to tutorials and stuff are in the description. This will be a pretty cool video because you're going to learn how to do some tricks with string management in Golang, messing with strings a little bit. You're going to learn different plotting techniques in Golang, which there aren't too many resources for that, so that'll be fun. And you'll also be learning a little bit about how to interact between Python and Golang, not in a very dynamic way, but in a very brute force, kind of doing it manually sort of way. So let me just show you guys the book that we're working on. I have a PDF copy. If you want to buy a copy, link is in the description, or you can go to nnfs.io. Excellent book, Neural Networks from Scratch in Python. Very cheap for the quality that you're getting. I say this in every video. Excellent book, but yeah, not but. I say this in every video. They're not sponsoring me. I just think that their book is an excellent book, and you should totally pick up a copy if you want to. But we're doing it in Golang. So let's get right into the meat and potatoes. I already have a file open. This is, I don't actually have the folder open. I should open the folder. So what I'm going to do is I'm actually going to open my folder. And as you can see, if you remember, or as you can see if you're joining us just now, the way I have it structured is I have it in chapters. So this is the general folder. I called it NNFS. And then I have it in chapters, chapter 2 and chapter 3. Chapter 1, there was no code. For now, actually, I'm going to make a new folder, even though we're still in chapter 3. And I'm going to call this folder getting data, because that's what we're going to be working with in the first part of this series, in the first part of this video. By the way, let's just read the beginning of the book, of this section, and then I'll talk about what I've been doing. Okay. Okay. So in the last video, we just finished adding a hidden layer, and now he's going to start talking about data. So next, rather than hand typing in random data, we're going to use a function that can create nonlinear data. What do we mean by nonlinear? Well, linear data can be fitted or represented by a straight line. So this is an example of linear data plotted. And as you can see, there's this little green straight line running through it, and it's pretty easy. You just do this using linear regression. This is nonlinear data, which cannot be represented in a straight line. As you can see, this is the best line you could do, but it's pretty bad, right? Like, you don't want this. If you were to graph data points from x comma y, where y equals f of x, and it looks to be a line with a clear trend or slope, the chances are they're linear data. So if you can make a line go through your data and it looks like it matches, like over here, then it's linear data, or chances are it's linear data. Linear data is very easy to be approximated. By far the simpler of machine learning models. You don't really need a neural network. What other machine learning algorithms cannot approximate so easily are nonlinear data sets. To simplify this, we've created a Python package that you can install with pip called NNFS. Okay, so they actually made a NNFS, they've actually made a function called spiral data, which they are using. So they import NumPy, they import NNFS, they initialize NNFS. They're using this to create random data in this spiral shape. Now, obviously, we're not working with Python, but if we want to follow along with the book, we're going to have to code a little bit of Python in this video because we have to get their data. That's all we're going to do. So if you don't know how to program in Python, don't worry about it. It's still going to be very easy. All we're really going to do is like these two, this line of code, and this line of code, and this line of code, and these two lines of code, to get the x and y values. The x values are the x and y coordinates. So x is actually going to be a two-dimensional array. If you don't know what an array is, check a previous video, but it's going to be a two-dimensional array. And the y is going to be a one-dimensional array which represents which data set each dot belongs in. Not data set, but which class each point belongs in. So as you can see in a later picture here, you have this spiral data set. It has 3 classes. There are 3 total classes in this data set, and there are 100 samples. So there's 100 points. And each one of the points belongs to a data set, belongs to one of these 3 data sets. And as you can see, he's plotting it. He's plotting it using matplotlib, using the first, in all of the, again, x is a 2-dimensional thing, so in all of the dimensions, in all of the values given by x, he's using the first dimension. You know, this is complicated to explain, but it's going to be simpler to code. In short, x can be broken up into this 2-dimensional massive thing. Each of the first dimension has 2 values. The first value is the x coordinate, and the second value is the y coordinate of these points. And then y, this data set y, is actually the color. And then as you can see, the color map that he's putting in here is a blue, red, and green. We're going to code something very similar to this in today's video, but we're going to have to code a lot of it because we don't really have a package as robust as matplotlib in Golang. We just don't. It's very unfortunate. So the first thing we're going to do is we're actually going to get the data. And to do that, I'm going to open up a new folder. Open folder. I'm going to open up the getting data folder, which, wait, I think I might have already done that. Yeah. Okay. And then in this new folder, I'm going to make a new file, and I'm going to call it getting data.py. This is going to be a Python file, actually, because we're going to have to code in Python a little bit. So let's see what he does here. So the first thing he's doing is he's installing NNFS. So let's make a new terminal. Where is it? Can I get a terminal, please? Thank you. New terminal. And I'm going to do this exactly. I'm going to do pip install, and you should be following along with this, pip install. And if you don't have pip, you have to download Python. Go to any tutorial on YouTube, how to download Python, how to get started with Python, and you'll get started with pip. There will be very little Python code. If you don't know Python, which if you know Golang but you don't know Python, that's a little bit interesting. But if you know Golang, you'll be able to read Python code easily. So this is how you install packages in Python. You use pip. And they made a package called NNFS. So pip install NNFS. We're going to install that. For me, it's going to say requirement already satisfied. So I don't have to worry. I don't worry about these warnings. I'm sure they mean something. But anyway, I have the requirement already satisfied. I already have NNFS, but you should download it. And then once we have NNFS, we could import it up here. So import NNFS. Now the next thing that he does, which is important to us, is actually he never imports. No, he does import NNFS. He needs it over here. But the next thing he does is actually from NNFS.datasets, from NNFS.datasets, import spiral data. This is just going into the NNFS package and then going into a separate package called datasets, and then data. This is a function that we're importing. And then we're getting this function called spiral data, which will generate our spiral data. Okay, now he does nnfs.init. He's initializing NNFS. All this does is, I think, set the random seed to something, to some value, so that we all have the same data that we're working with. That's why this line is important. Basically, we want to get the same data as him. We don't want it to be actually random. We want to have the same data that he was working with. So once we initialize NNFS, we can actually call x, y equals spiral data, and then we'll get 100 samples in 3 classes. So x, y equals spiral data, samples equals 100, and classes equals 3. And then let's print. This is how you print things in Python, x, and then let's print. I don't want to use matplotlib. I want to use as little Python as possible. And then let's print y. Let's just take a look at these two things. These are both going to be NumPy arrays, I believe. Okay, so let's run this. Run Python file. Great. Okay, so again, this should make it a little bit clearer. This over here is x. And here's like the first x and y values. This is the second x and y values, the third x and y values, like for each of these dots, and there should be 100 of these. Or maybe even more. Maybe it's 300. Maybe it's like, no, it looks like it's actually, no, it might be, does this look like 100 numbers? No. No, yeah, I don't know. 100's a big number, maybe. There might be 100 samples total. There might be 100 samples per each class. I'm not sure exactly. Maybe there's documentation. No, there isn't. Okay. So anyway, here are all our x and y values, and then here are all our class values. And we're going to use this to train our model. The model is basically going to predict, given a point, which class does it fit into. So now that we have these two things, let's actually copy and paste them, and now we're going to turn it from a NumPy array into a Golang slice. So let's open up a new text. Let's open up a new file, and we'll call this processdata.go, and package main. Sorry, hold on. Package main. Func main. Sorry. Now we're back to Go, which is great. And let's say raw x. This is the raw x equals, and let's actually make this a string. Now to make this a multi-line string, what you want to do is you want to use the backtick syntax, and then we can copy everything from here. Oh boy, it's a lot of lines. Yeah, okay. All right, so let's take a look at this. Excellent. Now actually, instead of having it as a string, I want to have this as an array of bytes. A byte array. Why do I want it to be a byte array? Because that will actually allow us to go into it and process it and mess with it, which is pretty cool. Okay, great. So that's our raw x. Now let's get our raw y. Raw y colon equals a byte array of, this will be a very similar situation, backticks. And now let's get the y values again. Let's copy all this over here. Excellent. Oh, that's weird. Okay, so that's interesting. So I guess for this case, it's not going to be backticks. It's just going to be straight up quotation marks. And let's zoom all the way to the other side here. It's a long thing. Okay, let's get rid of this terminal. Back to here. What's the error? There's an error somewhere. Comma? Yeah. Okay, so here we have an array of bytes for our raw x, and we have an array of bytes for our raw y. So let's just show what we can do here. So for now, I'm going to say underscore equals, or underscore colon equals x, just to get rid of the error. Why is x undeclared? Oh, raw x, sorry. Underscore colon equals raw x. No new variable on left side. Great, this will get rid of the raw x error so that we could just work with raw y for a second. So let's make a for loop. For I colon equals range. I believe I can do this. I believe I could range over a byte array. Raw x, not raw x, raw y. I want to fmt.println the string value at raw y index I. Because as you can see, this is not the syntax for a Golang slice, right? This is the syntax for a Python list. We don't want a Python list. We want a Golang slice. So to do that, we're going to have to loop through it and change everything because I don't want to manually do it. And anyway, code is fun, so this will be a fun project. Why do you guys both have warning signs? I have no idea. Can I have a terminal, please? I know that I just got rid of my terminal, but I want a new one. Okay, let's do go run everything. And here we see that everything in yeah, this is spaces, not new lines. So everything in raw y is either a space, it's a number, or it's a bracket, which is pretty good because what we want is we want to get this out as the syntax for a Golang slice, so that we could just copy and paste the output and make that into our Golang slice. So let's do that. Slice y colon equals, for now I'm just going to make it an empty byte array. just an empty byte array. And then, well, actually, I'm gonna make this into a byte array with a size of the length of raw y. Because for now we're just going to process raw y, and then later we'll process raw x. So now, as we go through raw y, there's going to be a few things. So if the string representation of raw y at index x equals, let's say a bracket, let's say an open bracket. If that's an open bracket, then I want to say that slice y at index I equals the byte representation of, and this is going to be single quotes for 1 byte, of an open curly brace. Okay. Now, okay, else if, and let's copy this condition because we're just going to switch it from an open bracket to a closed curly bracket, or so, to a closed bracket. So if it's a closed bracket, I want to do the exact same thing, except I want it to be a closed curly bracket. Now, if it's a space, because what we want instead of a space is we want a comma and a space, right? Because that's the syntax. So else if, very similar notation, except now I want to know if it's a space. Then slice index I. This is going to be interesting. This is going to be interesting. Okay, so instead of doing a make, instead of making this just a make thing, I'm going to make this an empty. Because now I want to add two things. Whenever it's a space, I want it to be a comma and then a space. And in order to do that, we're going to have to use append. So instead of doing it like this, we're going to say slice y equals append to slice y, the byte representation of. So now we're going to be using appends apparently instead of the I syntax. So let's copy this and put that over here, except now it's going to be a closed curly brace. And then same thing over here, except now it's going to be a byte array syntax of quote comma space. No, I can't do that. Just a byte syntax of quote comma space? No, I can't do that either. Byte array syntax of. How about I just do it like this? I'll just do a byte syntax of a comma, and then I'll do another append, a byte syntax of space. Okay, and I think and then otherwise, if it's a digit, I just want to append. Then I just want to append raw y at index I. Raw y, nope, not all of it, at index I. Okay, that should work. Where's the error? The error is at fmt, so fine, that's fine. Okay, now I want to say fmt.println slice y. That didn't work. I want to println the string version of slice y. Now we'll get a string back. Great, and as you can see, this is in the syntax of a Golang, what do you call it? A Golang slice. So let's copy this, and let's make a new file. We'll call this data.go. And what we'll do over here is we'll say var y, which is an array of float 64. We're gonna get used to working in float 64s now, because whenever we're working with data, we want a lot of precision. Even if these are integers, it's still nice to be working with float 64s for reasons that will be made clear later. So this equals an array of float 64. What's wrong? What's the error? Expected package. Sorry, I forgot the package. Package name. Okay. So now what I did here is I just copied this whole thing and I pasted it, and now it works. Let's actually change this to a capitalization just so that it doesn't throw an error or like a warning. Great, so now we have our y's. Pretty nifty. Let's do a very similar thing for the x. So the thing about the x, which is different than the y, so let's actually come over here and let's change this to raw y, so that now we're going to be working with x. So let's change this to slice x, which is going to start off very similar. And a lot of this is going to be the same, I'll be honest with you. A lot of this will be the same. Copy and paste, slice x, slice x, slice x. So if it's an open square bracket, then I want it to be an open curly bracket. If it's a closed square bracket, I want it to be a closed square curly bracket. If it's a space, now that's a good question. What should we do if it's a space? So we have a few spaces here, is the thing. And I want the spaces here to be a comma and then a space. Oh, that's interesting. Over here we also have two spaces. That's a problem that we have to solve. So over here we have a space that we want to just delete, really. And over here we have two spaces in a row, which we want to turn into a comma and then a space. So that's actually, so far that's the only differences that we have. Here we have two open brackets that we want to turn into two curly brackets. And down here, we should add another closed bracket here because we want to have an ending curly bracket. Okay, so all that's changed really, oh, and one more thing. We have a bunch of new line characters. So this is a new line character over here, which we're going to have to, if it's a new line character, then I want it to put in a new line character, which is fine because that's handled by this. If it's a digit or if it's a new line character, just put in that exact thing. So that will handle all these new line characters. That will handle all the digits and all the negatives. We want to keep the negatives as well. Golang fortunately supports E-02 as valid syntax for a number, which is very convenient. So all we have to do is handle for different spaces. So where do we see if it's a space? Here. So the only time that we would want to append a comma and a space is if the string if the string representation of raw, first of all, this needs to be raw x over here. All these raws need to be raw x. I'll just copy and paste raw. Nope. I'll just copy and paste raw x. And then whenever we see raw y down here, we'll put that as raw x, raw x, raw x, raw x, raw x. That's raw x. Slice x of a pen, yeah. Raw x. Great. Okay, now, all right, what is the situation that we want to make a space into a comma and then a space? Well, we want to make the space into a comma and then a space only if, okay, only if it's next to a space, or if it's not next to a space, but it's also not next to a bracket. So in other words, if so for these kinds of spaces, if the way we know that we don't want to make this into a comma and a space is that the previous value is a space. And for these spaces over here, the way we know is that the previous value is a bracket. But if the previous value is not a space or it's not a bracket, then that's a valid space that should be turned into a comma and then a space. So over here we can say if it's a space and the string at raw x index I minus 1 does not equal a space. Sorry, hold on. I put the does not equal in the wrong place. Does not equal a space. And Similarly, it can't equal a open bracket because there are spaces before, there are spaces after open brackets that we don't want to count as spaces. So only then, sorry, this should be slice x. Only then should we put a comma and then a space instead of that person's place. Sorry, there's a lot of nuances, a lot of the word space. We're just saying space a lot. Okay. The only thing I want to worry about right now is I minus 1 might throw an error. No, I minus 1 should never throw an error at this point because there are no spaces up here. There's one over here. And then it's going to check backwards, and it's going to see that that is open bracket, and so it won't add the comma and space. Yeah, open bracket. Okay. I think this should work for slice x. Let's run the program now. I don't know why it pounded out like that. And as you can see, this looks like, okay, why are there 3 spaces here? That's weird. Oh, I think I know. Why are there 3 spaces here? That is weird. Oh, because at this else statement, it's putting in all of these extra spaces. So I'll say else if the string over here does not equal a space. Let's run that. Okay, and as you can see, this is very nice Golang slice syntax for a 2-dimensional slice of int32s. So there you go. We could copy all of this. What the heck? Oh, there's a lot more. Okay, we can start off down here, and we can go. Continue going. Okay, we're going to copy all of this. We're going to go back to our data.go, and we're going to come down here. And we're going to say var x, which will be a 2-dimensional float 64 equals a 2-dimensional float 64 with the values. Oh, we don't even need curly braces. Copy and paste. Put this curly brace. Yeah, the curly brace could be. Let's put the curly brace over there. And then up here, there's no comma here. Ooh, we forgot. We should have put a bunch of commas after every close brace. We should have put a comma. Not bad. So after every close brace, let's actually also append a comma. Yeah, that's a good idea. All right, let's try this again. Let's run that again. Oh, what happened? Oh, there's an error here. Let's delete all of this. Or at least let's go like that. Sure, why not? Okay. Let's run that again. Okay, so now we have better syntax. We're going to have to get rid of 1 comma, but other than that, this is better syntax. Equals a 2-dimensional float 64. And we don't need to put in the brackets. Put it down there. Get rid of this comma. That comma can stay, and we'll put that curly brace down. And then, other than that, let's just bring all of these guys 1 indent in, maybe more, 2 indents in. I don't know, 1 indent in is fine. Oh, come back. Okay. Great. So there you go. That was what it took to get all of these values that he had. Now let's think about plotting it. So yeah, so as you can see, all he has to do is import matplotlib as plt and then plot it and then show the plot. And it looks something like this at the end of what he's done. So we're going to try and recreate something like this. And then, okay, and then he's going to start bringing things into object or into programming. So we're going to create something like this, and then that will be the end of the video. So first things first, let's do some file meddling. So let's open up our file. Let's go to our directory. So here we have chapter 2, chapter 3 on getting data, which is where we've been spending the last, I don't know, however long we've been spending. So let's go back into chapter 3. And here we have the, what is this? Oh, this is the Go mod file. Here's the main file. Let's make a new folder. Let's make a new folder. New folder. Actually, you know what? For now, let's stay in getting data. Let's stay in getting data for now. Yeah, for now, let's stay in getting data, and we'll work on the plotting system now. because I don't want to mess with the code in main.go at chapter 3, because this is a good code that we're going to come back to later. We're just not working with it right now. So I don't want to mess with this main.go file here. So for now, let's make a new file, and we will call this, let's make a new file. What will we call this? We will call this, you know what? No, we're gonna have to, yeah, let's come over here. For now, let's close this file. Is there a way to close files? Close folder. Great. All right, we're gonna close this folder for now, and so that we can mess with stuff a little bit, because I did not organize things properly. Let's go back to the directory. Excellent. So here we have getting data. Let's make a new folder, and we'll call this folder, we will call it, I don't know, we will call it, I don't know, data, CHP3 data management. And I'm calling it like this without underscores deliberately. And then we're going to put getting data into here. So this is where you would get the data. And now we're going to make we'll make a new folder. We're going to call it plotting, uppercase, plotting the data. And from getting data, we're actually going to copy data.go, and we're going to put it into plotting data, because we need the data. We need to plot it. Great. So now that that is set up, let's open up that folder. Why am I here? Makes no sense. NNFS, CHP3 data management, plotting the data, and let's select this folder and let's open it up. Okay, great. So here we have all the data that we got, and we're going to keep it in this separate file, and we're going to mess with it. So let's make a new file, main.go, and here we're going to plot the data. Package main, func main. So to plot the data, we're going to be using a very nice library that I found, best one I found, which is gonum v1-plot. You can find it, link is in the description. You can also find it on pkg.go.dev. Just go and type in plot, probably, and it will come up. Yeah, gonum.org v1-plot. And this is the link. So we are actually going to copy this link. And we're going to go into VS Code. And we're going to come over here, and we're going to import it. First thing that we should do first is actually make this into a module so that everybody will be on the same page. Let's do go mod init, and now let's say import quote that. Oh, I don't know why that's the thing that's copied. That makes no sense. Copy. Great. Over here. Why are there several? Oh, anyway. So now we have an error. Why? Because we have to do go mod.tidy. Not go mod.tidy, but just go mod tidy in the terminal. All right. And this is getting a lot of stuff. Wow. Okay. What you could do if you want, just by the way, what's the error here? Imported but never used. That's fine. If you want to install it, if you want to install gonum and just install this into your machine, which I've already done, you have to do go mod, go get, and then this. And then if you have any errors, you would have to install all of these. You would have to you go to your terminal or command line. You say go get this link. If you have any errors getting it or importing it into your files, you would have to go get all of these separately, because these are the separate packages that this package requires. Now, yeah. So for now, that's all we need. We'll go back to our main file, and we can come over here and we can make a new plot. So to make a new plot, we'll say p : plot.new. That's all we have to do. This is going to be the new plot that's like in the back end, and we'll throw all the separate little plot pieces like scatter plots or line plots or we'll put it on the p on this p colon equals. And then if we want to put, so for example, if we wanted to put a plot on it, we would say p dot add, and then we would have to pass in a plotter. Hold on. Oh, that's interesting. Yeah. Okay. Anyway, for now, let's just start things off. So instead of matplotlib, what matplotlib does is it actually makes a new window with your plot on it. That is not what we're going to do. For GoNum, you actually have to use an image file, or not have to, get to, whatever you want to say. So, and the way you write the plot to the file is you have to make a GoNum writer. So let's call this WT for writer2 colon equals p dot writer2, and this takes in a the length and the height of the plot, and it also takes in the format that you want the plot to be in. So let's do this. So let's say we want a 300 by 300 plot, and it's going to be in the format of PNG. And not only does this return the writer, it also returns the error. So let's say error. So writer2 and error. And then we can come over here and actually let's make a function. Func handle error. This takes in an error of type error. Sure. And then we can say if error does not equal nil, log dot fatal, and then we could just pass an error over here. Great. And now we could say handle error over here, and we'll pass an error. Great. The only reason why I'm making that function is because we're going to have to do that many times. Now next we can do is we can actually say path colon equals, let's just say plot dot png, and this needs to be a string. Whoops, daisy. And then we can say that the file, we're going to make a new file, and this will be os.create, and this will take in a path. And this returns an F and an error. And we can handle the error. And then after we handle that error, we can defer. And we're going to actually make an anonymous function that we'll defer to. We're really coding in Go now. This is a lot of Go stuff. So we're going to defer a function that we can run. And we'll say f.close. And we'll actually also, the reason why we're making this a separate function is we're going to have to say error equals f.close, and then we'll handle the error if there's an error, if there's a problem closing the file. Okay, great. So now we've opened and we've created it and we've opened this new plot.png, and what we can say is we can say wt.write2f. Wonderful. That is all we need to do. Whereas he wrote one line. Okay. Go run everything. Let's see if this works. So it created a PNG. Let's open it up. And there you go. We have this empty plot with the range of -1 to 1, which is very convenient because our data happens to also be between the range of -1 and 1. You can see all these e to the negative things. So our data is also between the range of -1 and 1 on the x direction and -1 and 1 on the y direction. Great. So now how do we populate our graph? Oh, it's an excellent question. So let's do that now. To populate the graph, to populate the plot, we would have to, before making the writer2, so let's first let's actually make all of the, before we make all of it into a separate function. We will be making all of this into a separate function, by the way. Let's first see if we can scatter some stuff. So to do this, we would say, we're going to make a new scatter plot, scatter, colon equals, and actually we have to import a new thing now. So it's going to be very similar to this, except v1 dash, what's the syntax here? Let's go back to PKG. Let's do plotter. Let's see if this comes up. GoNum v1 plot plotter. Is this what we're looking for? Maybe. I think so. I think this is what we're looking for. So let's copy this link. Let's come over here, and let's put that in here. And this needs to be in quotes. Great. So now that we have that, we can say that scatter colon equals plotter dot scatter dot new scatter. I'm going to make a new scatter plot. And what a scatter takes in is a bunch of plotter.xyers, which we can make for now. Yeah, for now we can just say xy's. It wants to take in a bunch of xy coordinates. So xy's will equal plotter dot xy's. Can I do something like this? Yeah, this is a bunch of, this is a list of xy. So it's this, okay, so plotter apparently has a type called x and y, and this is a list of x and y's. So probably we can even do something like this. We could say 0, 0, and there, that's one thing. And then we could say 0.5, 0.5. There, that's another point. And we could say we can actually probably say negative 0.5 and negative 0.5. There, here's a bunch of temporary x and y values, so we could say xy's over here. And then, this also returns an error, error. So now we'll handle the error, error. Okay. And then we can say p.add scatter. And I believe that's all we need to do. What's the problem here? Uses unkeyed fields. What? How about plotter.xy? That's the problem now. Uses unkeyed fields. I'm not sure what that error even means. I think this will work. I'm not sure what the error means. We'll see if it's a real problem. Run it. Okay. Yeah, looks like that worked. Image, and as you can see, we have a little dot over here. This is the 0, 0, this is the negative 0.5, and this is the positive 0.5. And you see that the graph adapts dynamically to the min-max values, which is pretty cool. Which is actually not pretty cool, awesome. I spent so long trying to find a library that will do that, and this one did it. The problem is I saw this library for a second and then left it because I thought that it wasn't good. There were problems that I didn't like about it. But then after days of searching, this turns out to be the best one. So we're going with this one. Anyway, now we have to, so now the trick is, how do we turn our data, and really the data that we'll be focused with right now is going to be x. How do we turn our x's, in fact, I would actually like the x's to be on top of the y's, please. So let's do that. How do we turn our x's into this xy's syntax? So I have an idea. The first thing that I want to do, now that we have the bare bones essentials for creating a scatter plot, is I actually want to take most of this, if not all of this, and make it into its own function. So let's say func plot. This will be a plot function, and with I'll say plot data. And the plot data will take in, first of all, data, which will be in the format that we have it, float 64, because that's the format that our data is. And then it will take in a path, which will be a type string. So this will be the path that we save the image to. Okay, that's all we have for now. And then let's take all of this from the main function and put it in here, so that we'll be able to call it multiple times. And now we don't need to say path, colon equals that, because the path is going to be set up. And in here we could pass in plot data and x, and the path will be plot.png. Great. Now we have to figure out a way to populate this xy's, plotter.xy's list thing with our data. So this should actually be pretty simple. Let's actually turn this from this syntax into a make syntax. Make plotter.xy's with a size. What will the size be? I think the size will be how many points will we have? How many xy's will we have? We will have as many as the length of our data, right? Over here. And then we can say that we want, what do we want? Right, we should go through all that. So for I colon equals range of x, y's, let's loop through all the x, y's, xy's index I dot x. Okay, so each one of these xy's has a dot x. That equals data index I, index 0, because that's the x value, and the xy's index I dot y equals data index I dot 1. And I think there you go. That populated all of it, and then we put it into the scatter plot, and then we plot, and then we add it to the plot, and then we write it to the file, and then we close the file. Or actually, no, rather we create the writer, we write it to the file, and then we close the file, and there you go. So that should do it. Honestly, that should plot all the data. Let's run that, and let's take a look at our image. And something's wrong. Something is very wrong. That is not our data. I will be completely honest with you. Something is very, very wrong. Is that our data? This is between the range of -8 and 8 for some reason. Very, very weird. Very weird. Now that is strange. Not sure why this is happening. I've done this before, and I have not had this problem. It actually worked really well when I did it. Maybe we're passing in things wrong. I want to pass in x index I index 0, x index I index 1, dot y dot x. It should be working. I don't know why this isn't working. It looks like we're only getting what, one class or something. I really am not sure. Did I pass in data wrong? Like, did I mess up the data management system that we had? Question. Okay. What I'm going to do, spoiler alert, there is a link in the description to a Google Drive that I have. Here, let's go to it. Edit. I just want the link to the Google Drive. I think it should be here. Link to the plot library, link to the Golang Tensor library. No, I don't have it here. Okay, so let's actually add it. Link to the post-processed data. And then let me open up the drive. So over here, drive, let's switch accounts. Excellent. Here it is. I have this. I have all the data that I made previously. So I just want to make sure that it's the same data. 2.9. I think it should be the same data. Yeah, 2.95269. Yeah, 9.64 e to the negative 3. Yeah, 2999646 e to the negative 2.9955. Let's make sure that's the same. 2.99555, yeah. So it's the same data. If you want this and you don't want to do all the previous things and you're having trouble or something with the previous part, just go down here and click the link and you can get all the data from the drive. So for now, the reason why I checked that is just to make sure that we have the right data, and I think we do. For some reason, we're just having trouble putting it in and getting the right graph out, because this does not look like this. I am sorry to tell you. Let me turn on the air conditioning for a second. Great. Okay. Let's get back to this. The data at index I index 0, we're passing in x. We're getting x from data. It is called x. Yeah. Okay. Very good. Let's check something out. Let's fmt.println xy's just for a second, just to get a taste of what we're doing here. Okay. So the first value is 0, 0. The second value is this thing. The third value is yeah. All this is working. Yeah, this is all correct. The plot is still wrong though. I can't figure out why. I can't think why. This, for some reason, it's going. This is really weird. This is really weird. That's 0, 0. I do not know why this is working. I do not know why this is not working, rather. Are we sure we're getting all of them? Negative 0.0776 data. Negative 0.76325. Wait, what? Wait, what? Wait, hold on. Hold on. Clear. Let's try this again. Let's make sure that we're getting the right. Make sure we're getting all the data. Negative 776325. 776325. And it's a negative and it's a negative. And this is the same. This is the same. Very good. Okay, excellent. So yeah, so all that is working. I wonder why the plot is wrong. Let's compare the data with the data from the Google Drive for a second. Let's actually compare it. So here's all the X data from the Google Drive. Okay, great, excellent. Just so that I know what's wrong, because it could be anything from like we didn't process the data properly to something's wrong with the plotting system that we're doing. So here, so this is all X. We know that this is correct X, so let's just call it CX. That's CX. And now let's print a few things. So fmt.println the length of CX equals the length of X. Let's make sure that they're both the same length for starters. False, they are not the same length. Okay, that's concerning. Okay, something is very wrong. Yes, something is very, very wrong. This is not the same end value as this. And yeah, I thought that there's very little X. Yeah, okay. Yeah, we did something wrong with the processing stage. So let's go back to where let's open a new folder and let's go back to getting the data. And we're gonna work this out. Something didn't go right. So let's make sure we're getting the right amount of samples. Yeah, we are getting the right amount of samples. Let's go to data.go and let's see. Let's go to processing data. Negative 7.76325. Getting the data. Ah, I think I know what's going on here. When I ran the Python file, when I ran the Python file, it probably truncated. No, it didn't. I probably just copied things wrong. Alright, so now I probably just copied the X values wrong. Okay, come here. Copy all of this. Go to process data. Paste that in place of these X values. Let's see if things increase. Yeah, okay, things definitely increase in size. So now we have the right X values, and here we process it, and here we're going to print out the string. So let's do all this now. Clear, go, run, everything. So processing the data here. These are all the correct values for our post-processed data. Let's copy all of that. Am I sure this is the right amount? I think so. Yeah, probably. Let's copy all of this then. Command C. In data, let's see if the size increases when we paste this in. Paste. Yeah, the size definitely increased. Great. Excellent. Excellent. Alright, so now we have the correct data. So let's copy this entire thing. And now let's go back to our other folder. Plotting the data. Open that. Yeah, open the folder, please. Plotting data. Oh, shoot. Did I do... Okay, yeah. Command-O. Open up the file. Plotting data. Select folder. In the data, let's rewrite our data file. Command-V. Great. Now we have a lot more x values to work with, which is what's supposed to be the case. Let's go back to main. And now let's plot the data again. Alright, sorry about that. Go run everything. What am I printing? Ah, printing these. Stop printing that. Let's check out the plot. And there you go. So this looks a lot more like his plot. One thing that we could do, I think this is like a rectangle. It's not really a square situation, is it? So we can actually make ours a little bit more like a square as well. I mean, a little bit more like a rectangle as well. We'll do like 350 by 300. And actually, let's increase the size a little bit as well. So 450 by 400. Run it. Plot. Okay. That looks pretty good. I'm a fan of this. Now, one other thing that we should do is, as you can see in his plot, he has colors. We want colors. So let's think about how we're going to get the colors. Well, the way he's doing it is that actually the color should be relevant to what the y is. So let's take a look at y again. We haven't really looked at y properly. So y is 0, 0, 0, 0, 0, 0, and then there's a bunch of zeros. Hold on. A lot of zeros. And then there's... Come on. Where are my ones? Okay, here we go. Here are a lot of ones. So there's a lot of zeros. And then there's a lot of twos. Oh boy. Come back. Let's actually go backwards. It might take less time. I don't know, it'll take just as long. So then we have a lot of twos as well. So we have a lot of zeros, a lot of ones, and then we have a lot of twos. Great. Okay, the zeros tell us that this one is in the 0th class. This one, this point, is in the 0th class as well. This point is in the 0th class. So each one of them gets a class that is determined by the index. So this is index 0, so it gets the class of y index 0. This is index 1, so it gets the class... This whole thing is index 1, so it gets the class of y index 1. This whole thing is index 2, so it gets the class of y index 2, and so on and so forth. So the last value will be of class 2. And he's actually using that for the color. So the color should be y. It's either 0, 1, or 2. And the color should map to blue, red, and green. So the 0th class is blue. The first class is red, and the second class, the second if class, the second index class is green. So we could set up a very similar thing. The way you do color in the GoNum plot system is you have to actually set a color to the entire scatter plot. So what we could do is we could come over here and we could say, after we check the handling and before we add it to the plot, we can say scatter dot gif style. Color is the color used to draw the glyph. Scatter dot glyph. What is this subtype? Subtype color dot color. So we could say scatter dot color equals color, which is a library in Golang. Color dot RGBA, I think. Undeclared name color. We have to import that. So let's import color. Color. Is that how you spell color? No. There you go. Color.rgba. And then you pass in the red, green, blue values. So let's pass in 255, 0, 0, 255. This would be red. Could not import color. No required module provides package color. Okay, fine. So let's do go mod tidy. Sorry, what's wrong? Cannot find path. Tutorial. Plotting data. What's wrong here? Because it does not exist. What's the go mod here? Yeah, this is the... run go mod tidy. I don't know. Why can't you import color? Color could not be imported. No required module provides package color. What about the fact that I'm coding in Go? Go mod tidy. I don't understand. Require hold on. Did that get did something happen? Something change? Huh? Huh? Not sure. Nope, nothing changed. Yeah, no, this is still an error. Okay, so fine. So let's say require color. Usage require module path. Not sure how to do this. In the last time that I did this, I didn't actually make it into a module. I think that's what's throwing it off. Maybe the link is not just straight up color. It might be like Golang something color. Let's see, color. Let's see. GitHub.com/color image / color package color implements a basic color library. Maybe, yeah, I think, yeah, so this is a standard library, so I think the link is image color. Okay, fine, that makes sense. So, image / color. Yeah? Yeah, great, that's how you do it. Sorry, my bad. And then over here, sorry, color dot RGBA. 255, 0, 0, 255. Excellent. So this will make the scatter plot red. Now, oh shoot, go run everything. So now, the only problem is the entire scatter plot is red, which we don't want. We want only certain parts of it to be red. So what we can do is, not what we can do, what I think we have to do, I'm pretty sure we have to do it like this, is we're going to have to make a different scatter plot for every single class. And then every single one of those scatter plots will color. So we'll make this into a for loop. We'll for every class, we'll make new XYs, we'll make a new scatter plot based on those XYs, and then we'll continue like that. Okay, so the first thing that we'll pass in is we'll make this similar to this system. We'll pass in colors. So the colors will be of type a list of float64. Float64. And why is it a list of type float64? Because basically we're going to pass in y. Just like he passed in y, we're going to pass in y. And yeah, so just like he did it, we'll do it, and so it has to be the same type. And then we'll also do a CMap. We'll also say that it should take in a CMap, and this will be an actual map, which is it's not going to be quite like his syntax, which is a string. We're actually going to make it a Golang map. We're going to map a float64 value, because again that's what the color values are. We're going to map that to a color.color value. Color.color value. Okay, and then over here we have to now pass in the y for the C, for the color, and then the CMap, that's interesting. What will the CMap be? Oh, sorry, lowercase y. I mean, it needs to be an uppercase y because that's how our thing is. What will the CMap be? We're actually going to do that. We're actually going to declare that over here. So let's do it underneath the y. CMap is going to be, var CMap will be of type map, and we're going to map float 64s to color, and this will, oh boy, that was weird, import quote image / color. Color. Oh boy, color. There we go. Can't spell. Okay. We're gonna map float 64 values to color.color values, and this will equal. And now let's actually make the map. So the first one will be 0. 0 will be, well, for his it's blue. So let's say color. Can I say color.blue? Blue? No, I can't do that. Color.rgb. RGBA. And the red will be 0, the green will be 0, the blue will be 255, and the alpha will be 255. And then 1, 2, 3, great. Instead of this being 0, it will be 1, and this will be 2. So all the zeros will map to a blue color. All the 1s will map to a green color. And to do that, we'll come over here and like that. And then all the 2s will map to a, sorry, all the 1s map to a red color. My bad. 255, and then this is 0. And then all the 2s will map to a green color, which will be RGB, yeah, like this. So 0, 255, 255. Excellent. And then over here, after the Y, we will pass in CMap for color map. Okay. And now what we will do is how many times do we want to loop through and make a new scatter plot? Well, we want to do it 3 times. In other words, we want to do it as many times as there are items in the color map. As many options for colors that there are, we want to do that. So we want to do it that many times. So we'll say for key, comma, element, colon equals range. This is how you loop over a map in Golang. Range of CMap. We're looping over CMap. For key element in range CMap. Let's make a new scatter, and we'll add the scatter to the plot. So yeah, so xy is colon equals make, and then instead of this being the entire length of data, what we will do is we'll actually just say that it's, should we make it the length of data? Nah, well, for now we'll just make it empty, and then we'll do a dot append syntax. So actually, yeah, we'll do a dot append syntax. So for I colon equals the range of xys, we want to say xys equals append to xys a new plotter dot xy with the values of x being data index I index 0. And actually, yeah, and the y, you know, here, come over here. We'll break open this append so that it all fits on one line. We want to append to xys a new xy, a new plotter xy, with the x value being data and the y value being data index I index 1. But we only want to do this. We only want to put in this new data point in our xy list. We only want to do that, and in fact this should probably be yeah, we should probably declare this up here. Var xys will be of type plotter plot dot, no, sorry, this needs to be of type plotter dot xys. Sorry if this is like the first day that I'm using this library, actually, so I'm sorry if I'm a little bit slow. And we're going to declare it up here so that we could use it. Wait, no, we never use it again. Sorry, no, we're not declaring it up there. We're remaking it each time for each scatter plot, and then we'll make the scatter plot. So this all goes into the for loop. Making the xys, putting the xys into the populating the xys, and then putting the xys into a scatter plot, and then coloring it appropriately, which we'll do in a second, and then adding that to the scatter. But we only want to append if it fits the current key that we're working on currently. Only if the color at index I, only if the color at index I equals the key, the current key. Then do we want to append it to the xys. And then lastly, we're going to use this element. The element corresponds to the color. We're going to color the scatter plot with element. Great. I think this should work. This will plot our graph with the appropriate colors, I believe. Something went very wrong. That's weird. What went wrong? P.add scatter. We should have seen an error if something wrong happened. I guess maybe it never satisfied. I guess this condition was never satisfied. fmt.print ln. Yeah, I guess this condition was never satisfied, so the plot never got populated with anything. Yeah, okay, fine. So this condition is never satisfied. I wonder why. Y data float 64 0 1 and 2. Those are all the keys. Here are all the. I wonder why this isn't working. Because we initialize this with a length of 0. So instead of looping through the XYS, which now has a length of 0, we should be looping through the data. Yeah, let's loop through the data instead. For I colon equals the range of data. And then we can go on forward from there. Good, that will probably work. Okay, now let's get rid of the print statement. And now this should work, I believe. I believe in miracles! And it works! And as you can see, you have this little circle up here with that little circle under it, and it's red. And yeah, everything seems to be the same as his. So now what we have is we have our data that he has, and we have a way to plot it in this file over here. And so now what I want to do before I end the video is put all of this back into our chapter 3 folder. So what I'm going to do is I'm going to open up a file explorer. You could do it with Finder or File Explorer or whatever. And I'm going to open up 2 of them, actually. I'm going to open up 2 of these windows. And what I'm going to do is I'm going to come to the project directory, which is right over here. In both of them, I'm actually going to do this, so I'm going to copy this path and I'm going to put it in here. Great. Okay, and now I want to move some stuff from here. Okay, so in chapter 3, first of all, I want a copy of the data just straight up in chapter 3 to get. So this is all our data. We can open it, and so yeah. So here's all our data. I want that just straight up in chapter 3, so we can access it. And then I want to make a new folder, and I'm going to call this plotting. So this will be the module for all the plotting. Like we have a module that has machine learning, which right now only has one function in it called add bias, though there'll be more stuff in there, I'm sure. So in plotting, I want to put in this main file over here, which has our function plot data. So I'm going to copy this main. I'm going to put it in here. And now I want to close this, and I actually want to edit this file a little bit so it doesn't have the main function. It's not supposed to have the main function because now it's a part of a greater package called chapter 3. So I want to edit this. So I'm going to open this, select, open with, I want to actually open it with Visual Studio Code right now to edit it. So just to make things not confusing, let's delete all this. And yeah, so first of all, this needs to go. And this needs to be capitalized. And the package cannot be main. The package must be, I need some data. I need some information real quick. In the go sum, is it the go sum or is it the go mod? I think it's the go mod file. I need to open with none of these, please. More apps, Visual Studio Code. I need the package name. Yeah. Okay, so now that I have this package name, this is the name of the module. The package will be. Sorry, no, I don't even need the package name. What am I talking about? I just need the greater file. So package, plotting, or something. Yeah. Yeah. Okay. What's wrong? Right. So this is just Visual Studio Code bugging out. Now, what we can do is actually I'm going to open up the folder. I'm going to open up the general chapter 3 folder. I want to open up chapter 3. This will make things a little bit easier, I think. So we have in our plotting folder, now we have a main, this shouldn't be main anymore. This should be, let's just call this plot data. Plot data. That's the folder, because it has the function for plotting data. What are the problems here? We need to do go mod tidy to get the plotting library. So let's come over here in our terminal. Go mod tidy. So yeah, so it's getting gonum and all that stuff. Great, that should do it. Let's check the go mod file. Yes, excellent. That is correct. And there's more errors. plot.new. What's the problem here? Cannot initialize one variable with two. What? Oh, this gets an error for some reason. I guess now there's a newer version of Golang plot. I don't know. But anyway, we could do this. So p comma error colon equals plot.new, and then we could say handle error, because there's also a function in here for handling errors, as you can see. Great. Now let's check. So great. So we have this function and plot data in our plotting directory. We have the machine learning thing. Let's go back into the main folder which has all of our tensors and stuff. And let's actually, yeah, we could print out this, but I want to try something. We also have the folder for data, right? So I want to try to plot our data. So let's say, so first we have to import it by going up here. Let's import plotting. Plotting. I believe that's how we do it. Yep, great. And now we could say plotting dot plot data. The data will be x. Let's actually expand this. X. The path will be, let's just say plot1.png. The color is going to be y, as it was before, and the CMAP is going to, oh sorry, this needs to be a capital Y, and the CMAP is going to be CMAP. This should work. There's an error up here for some reason. I don't know why this is here. Sorry, that was weird. Let's try this out. So let's go to terminal, and let's say go run everything. So first of all, it prints out the output from the thing that we had before. Remember, our second hidden layer had an output, so that prints it out because that's happening over here. And now we have this plot1.png, which is our plot. It's very good, excellent. You do not know how much work it took to prepare this video, because I knew nothing about plotting in Golang before this happened. So, good. I hope you enjoyed it. There. We didn't get many pages in, I'll admit, but we will pick up tomorrow, probably tomorrow, starting out with the dense layer class. Hope you guys all enjoyed. Any questions, comments, concerns, leave it in the comments. I will happily respond. Definitely I'll respond to you. I may not know what to do because this is all pretty new to me as well, but just send it in the comments. Leave a like if you enjoyed. Check out the other videos. Also, recently, I made a very fun video. In celebration of reaching 200 subscribers, I made a cool video making a fireworks display in Golang, and that was really fun. So check that out. It's somewhere on my channel. Until next time, I think that's everything. Have a great day, and I'll see you